I'm trying this new app. I'm trying some new software called Explain Everything. I don't know how it works, but we're going to give it a try. So you'll see right now, we're going to use this video right over here. We're going to watch that as an introductory to Chapter 3, and then we'll be back.
58 miles per hour. 65 miles per hour. 62 miles per hour.
Felt better. We're here today hitting some baseballs. We're going to look at, we're recording the miles per hour of the exit speed of your swing. And we're going to see if there's going to be a correlation between exit speed and distance you hit a baseball. Up till now, everything we've done has been with one variable. Now we're going to be dealing with two variables. We're going to be dealing with two quantitative variables, one in exit speed, the other one in the distance of hitting a baseball. That's good.
70 miles per hour.
That's it. What we did was we plotted the data points. After we came back from the field, we got out our whiteboard and we wrote down, all right, miles per hour, and then the distance the ball traveled. My one son was behind me with the radar gun. The other one was in the outfield trying to figure out how far the ball actually went. So we rounded everything up, and you look at this. This is our X variables. This is the Y's. The X are called explanatory, and we're going to use these explanatory variables to make predictions about the response variable. So what we did was we took the 58, 100. We go to 58 up to 100, we draw a point. Then we go 60, 90. So where's 60, 90? 60, 90 right there, and so on. We plotted all those points. What do? We always make a picture, and what are we looking for? Some sort of pattern. Here we're looking to see specifically if something is linear, and does this data go in a linear fashion? And it pretty much does. And you'll see we're going to be able to calculate something called the least squares line so that we can make predictions about the distance based on exit speed. And we're going to do that using the graphing calculator, not by hand. Before we, I want you to see, not all data is linear. This is the average exit speed of the ball for professional baseball players in MLB in 2015. Selected ones that I chose. And this is the distance the ball traveled. And I graphed it, and you'll see that data is not really linear. You can still make a least squares regression line like I did there, but it doesn't necessarily fit your data. And when you have a large amount of data like this, and this is just the first page, you won't use a graphing calculator or do it by hand. You can use software. You can create a graph just like this. It actually will put a line in there for you also. We're going to be dealing with a smaller set of data, so let me show you that on the graphing calculator. Here it is here. Sit back, relax, and watch the tutorial. After graphing it by hand, I'm going to give you a quick tutorial on how to do it in the graphing calculator. Small sets of data like this, it's easy to do by hand or in a graphing calculator. If you have a large set of data, like we'll see later in the MLB, you'd use a statistical software. You wouldn't use this. But we're going to be using the graphing calculator. So get to your home screen, second, quit, right here. Hit Stat, and you're going to hit Edit. Now I put the data in here already in L1 and L2, so you can do that now. These are my X values, these are my Y's. I'm trying to predict the distance the ball is going to travel based on the exit speed. This is my explanatory variable, this is my response variable. It's a different line if I want to try and predict exit speed based on distance. So after that, I hit second, y equals, I turn the plot on. I hit enter on here to turn that on. Go down, highlight this, hit enter, put L1 and L2 in there. Hit graph. You probably didn't get this, so hit zoom 9, and then it should show up right like this. Now my data is pretty linear, forming a line. That's what linear means. So let's see about creating a least square regression line. And again, we're just going to do it on the calculator. We'll do it in class another way so you understand exactly where it's coming from. But we're going to hit stat, calculate. We're going to use number 8, which is the least squares regression line. Number 4 is the same thing. It's for algebra. This one's for statistics. It's just written in a different way. So hit number 8. L1 are your x's, L2 are your y's. We're going to store this here. You're going to hit bars, y bars, enter in y1. Once I hit calculate, I hit enter. This is my least squares regression line, where this is my y-intercept, this is my slope. This is the correlation coefficient, and this is the coefficient. This is correlation coefficient. This is coefficient of determination, r squared. Correlation coefficient tells you the linear strength. We'll get into detail in this later on. Hit graph. Your calculator may not show this. I'll show you how to turn it on. You can just go into second, catalog. Go to D, which is diagnostics. That's what we're looking for. You want to go diagnostics on. I know there's another way, but that's the way I remember. Hit enter and enter again. You run the regression equation again. Stat, calculate, a same thing. I'm gonna store it. Calculate, enter. And if you hit graph, you'll see a line go right through the middle of your data. You use this line, you can use this line to make predictions about how far the ball will travel based on exit speeds. Now, this is based on the data that we have here. If you go beyond this data, they call that extrapolating, and really you don't know what happens beyond this, so you really shouldn't do that. All this stuff we'll get into more detail in class. Thank you.
Used to be one of my favorite songs.